What's up guys, I'm Ryan, I'm one of the tutors from the Econ Tutoring Center. Today I'm going to go over an example of a negative externality and how we can apply a tax to kind of compensate for a negative externality. Also remember that notation and language may vary by professors, so always check to confirm that the language we're using is the same as your professor's. So I'm going to go over an example of how a tax can be applied to compensate for a negative externality. So we have this market demand and market supply. And so first thing we can go ahead and plot that. Our supply will look something like this, and our demand will be here. And of course this is quantity and this is price. Okay, now we can solve for this initial equilibrium before we apply any tax. And that's just going to be setting supply equal to demand, so that's 50 minus 5p is equal to 6p minus 5, and that gets us that 11p is equal to 55, and so p is equal to 5. So that gets us this initial equilibrium price right there. And then we can find what this quantity is simply by plugging that into either one of those, which is going to give us, in this case, 30 minus 5, which is 25. So that is our market equilibrium, or I should say, before we apply any tax for the externality. So now we assume that there is say a $1 per unit negative externality. So if this is some factory and they're polluting or something, then for every unit they produce, there's $1 of negative cost to society that isn't being captured by the supply curve. So the first thing, remember that supply is really the same as marginal cost, and demand can be thought of as marginal benefit. So that kind of helps in these negative externality cases. It helps how we think about what we're doing to these curves. So in that case, we can apply, say, a $1 tax, a tax of t equal to $1 to try and compensate for that negative externality. So remember that the social cost, because there's a $1 negative externality here, the marginal cost, this is like the marginal cost of the market, the social cost is going to be $1 higher, right? Because this is like this, I'll call this marginal cost social, because this is, what the true cost, what society sees is the cost. Because obviously, the firm has to produce and has some cost that they have of producing, which is along this market supply curve. But in addition to that, society gets, has another $1 per unit cost because, of the pollution or whatever it is, secondhand smoke from smoking or something. So first of all, we can find what, if we applied this $1 tax to kind of compensate for that and to shift the supply to where it should be, then we would have this new equilibrium, which is actually the socially efficient equilibrium. And I'll show you in a second why that is. And that, again, is just by finding what this new supply curve is first, shifting that up by $1. So I will do that. I'll do quantity supplied, and I'll put a little s up here for social. And remember, we can shift that curve up by 1 by using this little trick of subtracting 1 from p. And I explain why that is in another video. But that gets us that the social supply is equal to 6p minus 6 minus 5, which is 6p minus 11. So I'll go ahead and erase this now that we know what that is. So we have our social supply, QSS, is 6p minus 11. And by social supply, I mean that's like the socially optimal supply. That is the supply that truly represents the marginal cost of society for each unit. Okay, so now we can find what this new equilibrium is, because remember, demand hasn't changed. The marginal benefit per unit is the same. It's just that this supply curve has shifted up. So now we can find out what this socially optimal equilibrium is here by setting the same demand equal to the new social supply. So we can do that by setting 50 minus 5p equal to 6p minus 11, which is going to get that 61 is equal to 11p, which I believe gets us this new equilibrium price of approximately 5.55, which would be right here. And then plugging that number into either the new social supply or the original demand would get us a quantity of about 22. Okay, so that is our new, we know this is the socially optimal equilibrium. So with the true marginal cost of society, this is, the amount that would be produced. So then we could say, well, because previously without any tax or anything to compensate for this, we were producing at 25 and 5, there must be some sort of deadweight loss associated with that, obviously, because we're overproducing, right? If the firm saw this true cost of 5.55, or this true marginal cost curve, rather, they wouldn't be producing back here. So they overproduced when that negative externality wasn't compensated for. So essentially, the value that they overproduced was, if we know this is the true equilibrium, where true marginal cost equals true marginal benefit, then over here, where they produce beyond that, we know that marginal cost up here exceeded marginal benefit, right? So this distance right here was the amount that society negatively was affected, or I should say that this would be, make up the deadweight loss rather, from overproducing, because in this whole region here, we're from 22 to 25 for these 3 units, marginal cost was greater than marginal benefit, or they oversupplied essentially. So we can actually calculate what that deadweight loss is. First of all, by just plugging in 25, we can find what this new P is here. Okay, so remember, this is a quantity. We're trying to find the price, so we have to plug it in for quantity over here. 25 is equal to 6p minus 11, which is going to get 36 is equal to 6p, and so p is equal to 6, and that gets us this the top there. Okay, so now we have all the information we need to calculate the area of this triangle here, because remember, it's just 1/2 base times height. We know what that is. So I can say that the deadweight loss is equal to 1/2 times the base, which is going to be 1 here, the 6 minus 5, times 3 from the height, which is 25 minus 22. So that's just going to get us 3/2. So we found the area of that deadweight loss there, which is $3/2, of course. So $1.50, I guess, is the proper way to write this. Okay, so I hope you see why this area there is in fact the deadweight loss, and also see how we calculated that. So then one of the other things we can calculate is, from this tax, what share of it is paid for by consumers and what share is paid for by producers. Okay, so remember, this was the initial price here, right? So that was the price that consumers had to pay for a unit, and that was the price in the initial equilibrium that that producers had to, that was their marginal cost anyway. So now what's going to happen is, when we move to here to 22 units, consumers are going to pay $5.55 because that's the new equilibrium, right? But this marginal cost market is still the cost that the firms see. They don't actually have to pay this. There's just this dollar in between that's going to the government for taxes. So we can find out actually how much of this tax was paid for by consumers and how much was paid for by producers, right? So consumers now face a higher price, and they have to pay this higher price for 22 units. So this entire upper region here is paid for by consumers, and obviously that's just going to be it's going to be 55 cents times 22, and then there's just going to be this lower region here because now producers are getting a lower price for each one of these units. They used to get to pay 5, now they pay some lower price here, which we'll calculate. They get to charge for each unit, which obviously hurts the firms, and so they pay this bottom portion of the tax here. So we can find out what those are really quickly. The blue area is just, I should say, paid by consumers, and that is just going to be 0.55 times 22, which I'll let you calculate that. It's going to be something like 11 point. It's like 11 point something. And then we can also find the area of this green, paid by producers. And now we could plug in 22 into this market marginal cost to find out what this lower point is right here. But we know that this distance the curve is shifted is 1 because that's how much the tax is. So this is just going to be 455 right here. So then that also is going to be, that's going to be 45 cents times the 22 units, which should be a little bit less than 11. So now we know that consumers, first of all, are paying a slightly higher fraction of this tax. And as I've mentioned in another video, that has to do with the fact that their slope is less elastic or more inelastic than the supply is. But again, that's for another video. Okay, hopefully that gave you a better idea of how we can apply a tax to maybe compensate for a negative externality, and maybe what some of the effects of that tax are.